Hello and welcome to Multiframe Webinar 2, Video 1 on working with properties. We saw in the first webinar how we can set up the geometry of our frame. Now let's take a look at how we can specify the properties of the joints and members we've created. For the joints, we can apply restraints to define the boundary conditions of our problem, and we can also specify the orientation of those joints in the case when we want the restraints to be at an angle to the global axes. As an alternative to a rigid restraint, we can use a spring at a joint to simulate external stiffness, such as the flexible support provided by a soil foundation. And when we have a rigid body within the structure, such as a floor slab or a shear wall, we can simulate that using master-slave or joint linking to link together a group of joints as a rigid body. When it comes to the property of members, we can specify the releases on members to specify the moment continuity at the ends, pinned or rigid, and for partial fixity we can use member end springs. If we want to model some arbitrary stiffness within the structure that's not explicitly modeled, we can specify a spring member and define the stiffness of that connection directly. Each member must have its section properties and material properties applied before analysis, and we also need to specify the local geometry in terms of its orientation within the structure. We can use some modeling commands to define the graphical layout that appears when we're rendering our structure, and finally, if we have some deep beams in our model, then we can specify the shear effects that need to be taken into account for those deep beams. For joint restraints, we can apply them in the global coordinate system in general, and we just choose a pin or a rigid or a roller restraint. That's very straightforward. In the case when the restraints are inclined, then we can modify the local joint coordinate system. And notice that in the dialog it says x-y-z- to indicate local coordinates that the restraints are applied in. To define those local coordinates, we just have to set up a local joint axis system that has an angle relative to the global axes. If we're applying springs to the joints in the structure, we're directly applying a certain amount of external stiffness, and we have the option there of doing that in global or local coordinates. We can see those buttons in the dialog. And in addition to that, we can specify that the spring be a tension or a compression only spring. And that's useful for soil supports where the soil provides compressive strength but doesn't really have any significant tension. So let's go over to Multiframe and see how this works in practice. Okay, so we have our structure here, and I'm going to create a sloping support at the base. So I'll just check the magnitude of that slope, and then we'll use the intersect command to trim our members off to that slope. So then we'll delete the members that we don't need, and we can select the nodes at the base of the columns and choose the joint orientation command. I can then paste in the slope and we get our local joint coordinates set up that way. Now if we choose a joint restraint, of course we can use our normal restraints, or if we use a pinned roller restraint, it's a bit more obvious that that restraint is being applied in the local axis system. If I select those same joints and use the joint spring command, then we can see we can apply vertical springs that are perpendicular to that slope, and we can see we can enter the stiffness of the spring, the orientation of the spring in global or local coordinates, and whether or not it's tension or compression only. So that completes our setup of basic joint properties. Thank you for watching.